Okay, so this is a continuation of all of the lessons that we've done so far, all of our factoring lessons. So just like on Friday, how we reviewed each type of factoring, today we're going to be combining. Okay, we're going to be using multiple methods to factor, just like it says. So we're going to be taking our steps that we have beforehand. We're going to be checking to see if there's a GCF. That's going to be the first thing that we do after we put our polynomial in the correct form. So our steps are, be sure that the polynomial is in standard form. So it goes from highest degree to lowest degree. Okay? And that means your lowest degree would be the term without any variables. Then you always start by factoring out the GCF. So you need to check to see, okay, is there a GCF? So that's why I was asking that question to you guys earlier. You always need to check to see if there's a GCF first. Then a side note on that is if your first term is negative, your GCF is going to be negative, okay? And if you guys remember when we were factoring by grouping, remember that first term in the second part of parentheses, if that was negative, we would factor out the negative? Yeah, so that's what that goes along with. Then we are going to count the number of terms. If it has two terms, we're going to see if it's a difference of two perfect squares. If it is, we're going to solve by that method. If it's not, we're going to use a different method, or it might be done. The next thing, if it has three terms, we're going to be factoring the x squared method or the ax squared method. And if it has four terms, we're going to be factoring by grouping. We need to be sure that the polynomial in the final answer can be factored again. Cannot. It needs to be prime. By the time we get to the end, it needs to be prime. No more factoring can be done. Okay? So we're going to look at what's inside the parentheses each time and see, okay, can something else be factored out? Okay? So, on this first one here, is it in standard form? Is it from highest degree to lowest degree? Yes. Okay. Is there a GCF? Is there a number that can go into both 4x squared and 16? 4, right? So I'm going to factor out a 4. So remember that means that we divide both by 4. 4 goes on the outside, and on the inside is going to be my quotient. So what is 4x squared divided by 4? X squared. And 16 divided by 4 is 4. Okay. Now that I factor out my GCF, I need to count the number of terms on the inside of my parentheses. How many terms are on the inside? 2. Okay, so 2 terms. Is it a difference of 2 perfect squares? Is x squared a perfect square? Yeah.
Yes.
Is 4 a perfect square?
Yes.
Is this subtraction?
Yes.
Yes, so this is a difference of 2 perfect squares. So remember when we have a difference of 2 perfect squares, we have 2 binomials. One is addition, one is subtraction, and then we find the square root of the 2 terms. So x squared and 4 squared rooted, okay? So what is x squared square rooted? X and x, right? So we're going to x and x. What is 4 square root? 2 and 2. But we have to always remember to bring down this GCF on the outside. All right, now looking at my parentheses. Is this a perfect difference of 2 perfect squares? Is this plus? No, it's addition. How about here? This is subtraction, but can I square root x or 2? No. Once you can't do anything to the problem, this is your final answer. All right. Is there a GCF in my next problem? Yes. What's a number that can go into 30, 30, and 75? 3. So my GCF is 3, so I'm going to factor out my GCF. So we're going to divide everything by 3. 3 is going to go on the outside. On the inside, we'll be left with x squared minus 10x plus 25. Okay, now that I've factored out my GCF, I need to look at how many terms are on the inside of my parentheses. How many terms are there? 3. Am I going to be using the x squared method or the ax squared method? Is there a number in front of x squared inside my parentheses? No, so I'm going to be using my x squared method. which means I'm going to find two numbers that multiply together to equal 25, but add together to equal negative 10. So I have a negative, positive, so what are my signs going to be? Negative, negative. And you're looking for 25, so 1 times 25, no. 5 times 5, yes. And 5 plus 5 is 10. So this is going to be x minus 5 and x minus 5. Remember, our GCF needs to stay on the outside. All right, anytime that you have two of the same polynomials, what do we need to do? Square. So I'm going to make this x minus 5 squared, but my GCF needs to stay on that outside. It's part of the answer. If it's not there, it's not correct. Ms. Holcomb? Yes. And there's nothing else that can be factored out here, so that is my final answer. Okay? Okay, is there a number that can go into 4x cubed, 20x squared, and 24x? 4x. So I'm going to divide everything by 4x. 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 So 4x is going to go on the outside because that's my GCF, and my on the inside of my parentheses is going to be my quotient. So 4x cubed divided by 4x would give me x squared. 20x squared divided by 4x would give me 5x. And 24x divided by 4 would give me 6. Okay, now we're going to look at the inside of my parentheses. What type of polynomial is this? It's a trinomial. Is there a value in front of x squared that's inside the parentheses? No. So I'm going to be using my x squared method where I find two numbers that multiply together to equal c, but add together to equal a. So I'm going to be, or b, I'm sorry. So I'm looking for 6. I have positive, positive, so my signs are going to be positive, positive. 1 times 6 is 6, but 1 plus 6 is 7. 2 times 3 is 6, and 2 plus 3 is 5. So I'm going to have x plus 2 and x plus 3. And I need to make sure I bring down my GCF. If that GCF is not on the outside there, the entire problem is incorrect. Right, now I need to look inside my parentheses. Is there anything else that can be done? Are these a difference of two perfect squares? No. Are they the same thing like up there? No. So this is my answer. So we're just combining everything that we've already learned. Okay? Okay. Is there a GCF? No. Okay. Are these a difference of two perfect squares?
Yes.
Yes. There's a difference, and they are both perfect squares. So I'm going to square root 16x to the fourth, and I'm going to square root 81y to the fourth, and I'm going to get two binomials. One the sum, and one a difference. 16, the square root of 16 is 4, and the square root of x to the fourth is x squared. So that's going to be 4x squared for my first terms. And then 81, the square root of 81 is 9. And y to the fourth is going to be y squared, y squared. Okay, my first binomial here. Is it a difference of two perfect squares? They're two perfect squares, but is it a difference? No. So that's my final answer for that part. How about my second binomial? Is it two perfect squares?
Yes.
Is it a difference? Yes. So I need to do what we did up here again. So I'm going to square root 4x squared and square root 9y squared, and it's going to be two binomials, one the sum and one the difference. The square root of 4x squared is 2x. Square root of 9y is 3y. 3y. Okay. Now, is there anything else that can be done to all three of my binomials there? No, this one is not a difference of two perfect squares. Neither is this one, and neither is this one. They're opposites. They're not squared. So this is my final answer. Okay, so on our list, the first step is to make sure it's in standard form. Is my first one in standard form? Yes, it's in descending degrees. Yes. Yes. All right, and then my next step says, always start by factoring out GCF. So is there GCF? Yes, 5A. So I'm gonna factor out 5A. So everything's gonna be divided by 5A. 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 5A is gonna go on the outside because that's my GCF. And then my quotient, after dividing, is gonna go on the inside. So I'm gonna have A squared plus 6A plus 4 or 8. All right, now that I factored out my GCF, it says to count the number of terms. So there's 3 terms on the inside. So which method am I going to use? The x squared or the ax squared method? X squared. So I need to find 2 numbers that multiply together to give me 8, but add together to give me 6. And they're both positive. So it's going to be positive, positive. 1 times 8, no. 2 times 4? Yes. So I'm going to have A plus 2 and A plus 4. Okay, and my 5A needs to stay on the outside. Now I'm going to look at my 2 binomials again. Is there anything else that can be done to them? Is there a GCF? Is there a perfect squares? No. So that's my final answer. Hey, my next one, is it in standard form?
No.
No. I need to write this in standard form. So I'm going to have negative 7m to the third plus 28m squared minus 21m. So now is it in standard form? Yes. Now it says always start by factoring out the GCF. So what is my GCF going to be? 7n. And because our first term is negative, we're going to make it a negative 7n as they're going to be our GCF. So I'm going to divide everything by negative 7n. So negative 7m is going to go on the outside. And on the inside, I'm going to be left with m squared minus 4m plus 3. So I have negative, positive. So my signs are going to be negative, negative. And I'm looking for multiples of 3. So 1 times 3 and 1 plus 3 is 4. So I'm going to have m minus 1 and m minus 3. And my negative 7m needs to stay on the outside. There's nothing else that can be done, so this is going to be my final answer. Is this in standard form? Yes. Is there a GCF? Yes. 5x squared. And 45x to the fourth divided by 5x squared is going to give me 9x squared. 20 x squared divided by 5x squared is going to give me a negative 4. Okay? In the inside of my parentheses, how many terms do I have? 2. So it's a binomial. Is it a difference of 2 perfect squares? Yes. So that means I'm going to make 2 polynomials, one the sum, one the difference. Remember my GCF is going to stay on the outside. And the square root of 9x squared is going to be 3x. 3x. Square root of 4 is 2 and 2. Hey, is this in standard form?
Yes.
Yes. Is there a GCF? Yes.
Yes.
6, x, y. I'm going to divide everything by 6. Everything has an x in it, and everything has a y in it. So I have 6xy on the outside. And after I divide, I'm going to have 3x squared minus x minus 10. Okay. How many terms do I have on the inside? 3. Okay, so what method am I going to be using? ax squared because there's an a. So I need to multiply a times c. Okay, so that's going to be 30. We're going to rewrite our problem. I'm going to make sure my 6xy stays on the outside up there. So I'm just going to keep writing that down every single time I make a step. Okay, so now I need to find two numbers that multiply together to equal 30 but add together to equal 1. I'm going to have a positive negative. That's equal negative 1. And what could they be? I mean, we could do 1 times 30, 2 times 15, 3 times 10, 5 times 6. 5 times 6? Yep. So I'm going to have x plus 5 and x minus 6. With my ax method, what do I have to do next? I will be writing my GCF, yes, but that's, what do I have to do with this part? I need to make my, yes.
You need to make the x, the 3 the denominator.
Yes, I need to make 3 the denominator. And then I'm going to reduce. So I'm going to still have my 6xy here. Can 5 over 3 reduce? No. So my 3 is going to go on the outside. My 5 is going to stay as the second term. Okay, what about 6 over 3? Yes. To 2. And then that is my answer.